Have you ever looked at something way off in the distance, like a mountain or a ship, and thought, how in the world could I figure out how far away that is? Well, today, we're going to move past the basics of right-angle triangles. We're unlocking the tools that let you solve for any triangle you can think of. And we'll start with a classic problem. Okay, picture this. You're standing on a beach. You see a ship out on the water. Now, your friend is standing, say, a kilometer down the shore from you. You both measure the angle from the shoreline to the ship. So now you've got two angles and one distance. How do you use just that to figure out exactly how far away that ship is? It's a real-world navigation puzzle. And right here is where we kind of hit a wall with our usual geometry toolkit. I mean, your trusty old friends Pythagoras and SOHCAHTOA, they're amazing, but they have a catch. They only work if you have a perfect right-angled triangle. But most triangles out there in the real world, like the one between you, your friend, and that ship, they just aren't that neat and tidy. So what do we do then? Well, we bring in the big guns. Meet the sine rule and the cosine rule. Think of these as the two master keys that can unlock the missing sides and angles of any triangle. It doesn't matter what its shape is. These are the power tools you grab when things get a little more interesting. Now, you have to think of these rules like different tools in a toolbox, right? You wouldn't use a hammer to turn a screw. You've got to know which one to grab for the job. So the sine rule, that's your go-to when you have what I call a matching pair. That means you know the length of one side and the angle directly opposite it. The cosine rule, on the other hand, is what you use when you don't have a pair, like when you know two sides and the angle that's kind of squished right between them, or when you know all three sides but none of the angles. All right, let's put our first tool to the test. The sine rule is all built around this really simple but incredibly powerful idea of balance. There's this consistent relationship that exists between the sides and angles of literally every single triangle out there. And the rule itself? It's actually pretty elegant. It just says that the ratio of a side's length to the sine of its opposite angle is the exact same for all three sides. So side A divided by the sine of angle A is equal to side B divided by the sine of angle B, and you guessed it, that's also equal to side C over the sine of angle C. It's this perfect consistency that we can use to find whatever we're missing. So, how do we actually put this thing to work? It's really just a simple four-step recipe. First, you look at your triangle and you find a complete pair that you already know, a side and its opposite angle. Easy. Second, you figure out which piece you want to find and you look at its opposite partner. Third, you set up the equation using just those two pairs. And finally, step 4, you just solve for the missing piece. That's it. But what if you look at your triangle and you don't have a single complete pair? Not one. In that situation, the sine rule is totally useless. And that's when you reach for the other really powerful tool in your kit, the cosine rule. Now, I know, at first glance, this formula can look a little intimidating, but it's actually just a souped-up version of Pythagoras' theorem. See the a squared equals b squared plus c squared part right at the beginning? That extra bit on the end, the minus 2bc cosine a, is just a correction factor. It's what makes the rule work for any triangle, not just right-angled ones. And you can see we can also flip this formula around to find a missing angle if we happen to know all three sides. And using it is just as methodical. First things first, you look at what you've got. Do you have two sides and the angle between them? Or do you have all three sides? That tells you which version of the rule you need to use. Then, and this is the important part, you just have to be really careful when you substitute your values into the formula. After that, you solve. It's all about being precise. Okay, so we've got the formulas. We know how they work. But the real skill here, the thing that engineers and navigators have to master, isn't just memorizing equations. It's the ability to look at a problem and know instantly which tool is the right one for the job. So let's put you in the driver's seat. You're handed the blueprints for a bridge, and it's full of triangles, angles, and lengths. You need to find a missing value to make sure it's stable. Before you even touch your calculator, what's your first strategic move? Your first move is to figure out what you've been given. And this table, this is your cheat sheet. As you can see, if you've got two angles in any side, or two sides and an angle that's not between them, you're going to use the sine rule. But if you have two sides and that included angle, or all three sides, that's a job for the cosine rule. Honestly, it all boils down to one simple question. Do I have a matching side and opposite angle pair? If the answer is yes, grab the sine rule. If it's no, it's got to be the cosine rule. So there you have it. You now have the complete toolkit to measure and solve any triangle.
anywhere. You can figure out the height of a skyscraper from across the street or find the distance to that ship at sea we talked about. You have the rules. The only question left is, what are you going to measure first?